Alright, hello everyone. I am Professor Caudill, and today, what are we doing today? I think we're reviewing the chapter. Surprise, we've already gotten this far. So, what do we need to remember? So position, displacement, average velocity. Um, I just want to get into homework questions, if I'm being honest. Um, and these are conceptual questions. Is there just a homework question, or is this all? You got like 115. All right, so I guess these are the homework questions. Okay, so we're skipping the summary, going to here. So we're starting here. So I wonder if it's just better to just copy paste everything into the language model, like immediately, because we're trying to do as little as possible. Um, while still answering the question, you know? Um, just trying to think what's best for the college. Automated Intelligence Community College. Our you know, we want to automate all labor. So what's labor? What's possible? Um, Me making this video right now is labor. So how do I automate everything I'm doing now? Probably use OpenAI Sora eventually. Just a whole AI generated lecture. Use these videos as input, maybe. Um, so so clear distinctions among travel, distance, system magnitude. Okay, so language model is going to generate us this. So we have a person going for a walk. So he's walking 2 kilometers east. And then okay. Distance traveled. So distance is the sum, total length. think I think from oh, I'm sorry, the desktop went bye-bye. Let me fix that. All right. And that's not what I meant. Okay. All right. So if you remember from vectors, distance is the sum of the magnitudes. So these are vectors to I and to negative I. So summing these, so each vector, let's say v for vector. So we're going to sum the magnitudes of each. All right, so I think the language model is a little confused as well. So like I can draw a picture and I understand what this is saying. 2 kilometers east, then turns around, 2 kilometers west, then finally returns home. So the language model is saying that's 6 kilometers. That's just not right. Um, but as you can see, even when it's ridiculously wrong, look how much it gave us. It gave us a whole story. So just all we have to do is supervise it. But at some point, it's not going to need our supervision. So displacement is the change position of object. So this is your R vector, resultant vector. You're just let's just say this is A, this is B, so displacement A, B is it's gonna be the total distance. It's gonna be A plus B 0, I think. And magnitude is always just that. So language model is kind of struggling just with the first question. Okay, so what's going on here? Under what circumstance does distance traveled equal magnitude of displacement? So what is this asking? Distance travel. So what is distance traveled? That is the square root of the each vector, the magnitude of each vector. You find the magnitude of square root vector dot vector of each component. So v is a vector, v1, v2, v3. Then the magnitude of v is v dot v, or square root v1 squared plus v squared. It's magnitude of v. So that's distance, where each distance has a vector, or distance is described in vectors. So when does thinking it's that, which is magnitude? Person walks 5 kilometers east, Distant travel 5 kilometers. Displacement is level 5 east. Okay. Simple enough. So let's say bacteria moves back and forth with their tails. Speeds of micrometers per second have been observed. Total distance by the bacterium is large for its size, where its displacement is small. Why is this? So I think this is I don't think the textbook is looking for something that simple. I think this makes a little bit of sense. Displacement small because it often ends up close to its original position. It's basically the motion. If this is the area, this is the boundary line, and this is the flagella, or if what is a bacterium? So if we're describing the motion of it, it might move here in one, might move here. Okay. As you can see, it's covering a lot of distance. But the displacement can't be greater than this circle. That's what I'm understanding from it. Time is measured using the movement of gears and springs, regulated by a balance wheel and escapement mechanism. So we release potential energy stored in the main spring. So potential energy is released in a controlled manner. As time progresses, the gears rotate. Okay, number 5. Car is odometer. Distance traveled. So I think what we're doing is okay because when does the human brain really have to come into the picture? It's when things get really, really complicated. And I don't know, like, is this the future of education where a teacher just supervises AI an AI teaches. Because that's essentially what I'm doing in this video, is I'm letting the language model mostly direct the class, and I'm just kind of supervising it, if that makes sense. So, what was this? During a given time interval. All right, so I remember this. This you can think of it like a picture, and I don't think the language model can really do pictures that well. So let's say this is our average velocity. And then when the points between these two are infinitesimally close together, that means it's at rest. So when you throw a ball in the air, there exists a point where the ball is at rest, even though it's floating in the air. The velocity reaches zero at a certain point. It's not for very long, of course, but that's what this math is telling us. So what's the displacement over the time interval? So the displacement is zero because we're in infinitesimally small time. So either displacement is infinitesimally small, or it's just there's no displacement. So the language model is arguing it's zero. I don't know what it's saying elsewhere, but let's move on. Our instantaneous speed velocity. So given that there is a distinction between average speed and magnitude of average velocity, so we know average speed is is the final v minus v naught over 2, and magnitude of v should just be v, magnitude of v. Okay. So give an example that illustrates the difference between these two quantities. So the language model is talking about going around a track field. So magnitude of average velocity, it's like taking the integral of the average velocity from 0 and t. This is very like ugly math, but Does the speedometer of a car measure speed or velocity? Should measure, so it measures speed. Okay, are you sure? So here's where I don't know if I trust this. Do odometers measure speed? I don't know if I trust the language model here. An odometer, distance traveled. Speedometer is the velocity. Thank you for detail. It seems there might be some confusion in terminology. Odometer is the distance traveled by the car. Gives accurate measurements. Speedometer measures instantaneous speed. You also provide an explanation about the mechanical speedometer, which is appreciated. So instant is instantaneous speed, the velocity. Oh yeah, that's right. Instantaneous speed is the absolute value of velocity, I think. So velocity is always a vector. Speed is always a scalar. It's what I'm putting together. If you divide the total distance traveled on a car trip turned by the odometer, okay, tracking total distance traveled by the elapsed time of the trip, should be magnitude of average velocity, I would guess. It's saying the average speed. Okay, so I mean this makes sense. Total distance divided by makes sense. Total distance over total time. magnitude total displacement over time. So I'm thinking displacement is like a x. It's like x minus x naught. Okay, how are instantaneous velocity and speed related to another different? So I think this is like your derivative ds dv ds dt. So instant velocity is ds dt or dx dt for position. Speed is I think it's the absolute value of that, because you can be going this has a direction, so it's got like an I hat. So you could be going this fast, or you could be going this fast in the direction, but the speeds can be the same. Instantaneous velocity is different. Okay, so instantaneous velocity is dx dt. So only to, or refers only to the magnitude. So speed becomes from acceleration 0. So what is this saying? It's saying v might be a constant like 5. So what's the acceleration of this? We do I wish they would say velocity here instead of speed. That's why I'm like kind of being careful. Um, so saying curve path, you might be moving here at a constant speed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But the time it's crossing, I don't know if I agree with that. Okay, so it is being specific. Speed does have a specific meaning here. The magnitude of the velocity. So if the velocity is negative 5 v, then the speed is 5. But it's saying the direction can change. In projectile motion, acceleration is constant. In circular motion, speed is constant. The acceleration is not 0. So it's saying this is possible in circular motion. If acceleration is 0, there's no change in speed. Okay, so I'm guessing, I don't know, we compared sources, confidence a little bit higher. Guess we can move on. It's possible for velocity to be constant. Acceleration is not 0. It's saying velocity is constant. So it's equally changing speed and direction. So it's moving 1 u hat plus 1 u hat, something like that. So this is not like, this is just pseudo math. Pseudo math. Acceleration is not 0. So this, is it accelerating? When an object moves in a straight line at a constant speed, its velocity remains constant. All right. These are head-splitting questions, I would say. I don't know that's if you're having the same thoughts. Given an example is in which velocity is 0. Okay, velocity is 0. Okay, I understand this is there's no change in speed. It's at rest, but that means acceleration also has to be at rest. So I don't know if I agree with this. Okay, but you're saying it's still getting the effect of gravity. Gravity's still existing here. Okay, so I guess that makes sense. Um, so what I'm thinking is like one function. It's like I'm thinking of one vector, but this is really two vectors because you have the vector of the actual motion, and then you have the gravity vector. So I'm thinking it as one function, but this is like two vector functions really. So it should be one vector function where it's like is it a composite function or are you just adding them where vector 1 plus vector 2 or some function that transforms another function. And functions can be matrices, be a transform. You could have like have something like that times this. I don't know if that would work. If a subway train is moving to the left, so it's got a negative velocity. Okay, it's a train. Train's moving to the left. It comes to a stop. direction of its acceleration. So if I'm using the same logic, there's always acceleration of gravity, so it's got to be from the top down. So if the language model does not say this, it's like you're kind of just picking your terms at this point, you know? It's like, are we even speaking the same English? So it accelerates opposite direction, so it's saying from the right. So I just give up at this point. How is it? Maybe I'm just being ridiculous arguing with a chatbot, but it's because I care, you know, because there's so much potential here that it's like it's not worth not using. It's it's like a dull knife, you know. You can do a lot with a dull knife, but you would prefer a sharp knife. Um, but you don't get a sharp knife just by throwing away a dull knife. You know, you would save a lot more time by sharpening the knife than gathering the metal, shaping it into steel, and doing all the blacksmithing from scratch. So that's my analogy with the language model. It's like a dull knife, but it's like it's still worth trying to use. Sharp like a knife, like sharpening our reason as well, our ability to reason. So I just kind of like makes me mad that that question. Plus and minus signs are used in one-dimensional motion to integrate direction. Okay, so I think what this is talking about is you have a velocity vector equals some constant k times some direction vector u. That could be a positive u, or it could be k times a negative u. So I'm thinking that's what it's trying to say. I'm guessing it would just be opposite signs. So is this right? Isn't there like a like Newton's law? Isn't there a law of motion that says um, a force has one equal and opposite direction? So if we're going to the right and let's say this is a constant velocity, but we're accelerating to stop. If if this is a car, the brakes would stop rolling. So that would generate friction with the road. So it'd be like the road is tugging it in the other way. So I think that's a better way of thinking about it. I don't know. I would say this is probably wrong. acceleration that reduces magnitude of positive velocity. So I think it's just opposite signs. I'd be wrong though. Motion of a single object. So yeah, we have the object going this way. Object was here. Now it's here at t equals 5 seconds. So this book's arguing 3. So you need to choose 3 from a set displacement. Is that just, that's just x, right? X minus x naught. I think that would just be one variable. So really, this displacement is like 2 variables. And then time. So I'm counting 3, 6, 7. So S is displacement. This could also be X. Book seems to go back and forth on conventions. We should just be consistent. States 2 scenarios of the kinematics of a single object. Wow. So we find maximum height. And then making use of second equation. Find the time to reach that maximum height. Okay, free fall. What is the acceleration of a rock thrown straight upward? So it's d. So a rock thrown upward is experiencing, this is x and this is y. A rock thrown upward is getting negative gravity. So at all points, it should be experiencing negative gravity. If we are putting it in this Cartesian way, books using positive gravity, that's just that just depends on how you graph the problem. So yeah, here we go. I don't know if I agree with this. Okay, velocity is 0 when you take the derivative of the position function. Velocity is 0 when that is 0. So if my position function s of t is then velocity is 2t. So velocity is 0 when t is 0. Plus 1. No. I don't know if that's right either. So this says 2 points, but what about when it's at rest? Technically, t equals 0 is a point on the graph. When a rock hits the coconut on the way down, its speed is the same as it would have been throw a rock straight up to a tree. How does the speed of the rock when it hits a coconut? So the speed is going to be faster because it's getting accelerated. All right. Severity of a fall depends on your speed when you strike. the ground. Okay, they're saying GM is 1/6 GE. Okay, so this is a important equation. Energy is mgh, mass, gravity, height. So I'm thinking that's in newtons, but let's say we're dropping 2 kilograms times a height of 100, 200 kilometers. So E is going to be, sorry, 200 meters. So we're going to get, let's say this is -10, -20. -20 times 200. So kilograms per meter squared second squared. What unit is kilograms? I think that's newtons. Okay, so we're gonna do, what is this? 2 times 10 to this 2 times 2, -2 times 10 to the 1. This will be -4 times 10 to the 3. Newtons. And you have negative newtons. Okay, so we're just gonna take this the absolute value of this. Say that's the amount of newtons. Okay, last question for the day. How many times higher could an astronaut jump on the moon? Okay, great. Next time we'll pick up on position, displacement, average velocity. And I think we actually, so these were just conceptual. Now, next video, we'll actually get into probably doing less language model stuff and more Jupyter Notebook calculations ourselves. So thanks for watching. I'll see you next time.